Okay, page 62. Okay, so what we're going to have a look at, I know you did a bit of this with Joan already, so I think it's good if I do it again when I don't have a full class, because there's a lot of people are missing. So logarithms. So firstly, what do I mean by log? Log for short. So when I write something like this, log 2, 8. Maybe someone remembers, what's the 2 called? Base. And the 8? No? Argument. So the meaning of something like this, log base 2, argument 8, it's literally asking you 2 to what power will make 8. That's what I'd like to know for this. So what would be the answer here? It would be 3. So that's what we mean by log. It's asking you what power to put on 2 to make 8. Okay, so let's just do another example. What about log 10 100? 2. Yeah? What about log 3 27? 3, isn't it? Okay. So that's what I mean by log. It's a way of getting the power. So just like the last class we had rules with powers, we also have rules with logs. Can I go down? Yeah? Okay. So the first rule log base b of x multiplied by y, that's log base b x plus log base b y. And I'll give you a small example of it working. If you said something like log base 3 9, but 9 is 3 multiply 3. So using this rule, it says that should be the same thing as log base 3 3 plus log base 3 3. What's log 3 3?
1.
So together this is 2. Is that the same as log 3 9? Yeah. So we'll do the proof of the rule now. So the proof, what we do is we say let x equal bn and y equal bm. So then log b, bn, bm, because that's x and y now, that's equal to log b, b power n plus m, using the first rule of powers. What does this equal? Log b, b n plus m. Yeah. this is n plus m. Because here I'm asking you b to what power makes b power n plus m? The answer is n plus m. Now if you look at n, I could write that as log bx. Because I could say b to what power makes x? Well, if I go back here I can see it's n. b to the power of n makes x. So this n can be written as log bx, and then the m log by, because b to what power makes y, the answer is n. So that m can be written like that. And that's actually the proof of the first rule. Okay, so write that down. And then we'll do the second rule, which is so similar to the first rule, I'll just make small changes to the first rule. So the second rule log b x over y is equal to log b x minus log b y. Okay, and the proof, I'll just do it in red by changing the last proof. The only difference in this rule is that instead of multiplying here, we divide. So I put a divide here. If that's divided, what changes here? Minus, minus, minus. So that's the second rule proved. So you can just even make a small change with a red pen or something for the second rule, the proof. Okay, rule 3. Log base b x power n equals n log base b x. In other words, you're allowed to take powers down in the front for log. Okay, so let's have a look at the proof here for this one. So again, let x equal bm. So we have log base b xn equals log base b bn n. That equals log base b b mn. Is this okay so far? So what I'm doing here is I said x is bm, so here I replace x with bm, and then here I'm using, I think it was rule 3, wasn't it, from the last class, that when I have two powers like this, they can multiply together to make that. Okay? Okay. Next, this is equal to mn. Can you see why? Because I'm saying b to what power makes b power mn, and the answer is mn, which equals nm, which equals n log bx. Because b to what power makes x? If I go back here, I can see it's b power m makes x. So this m here, I can just replace it with log bx. So this is the result that I wanted at the end. So this is the end of that proof. Okay, do you have those? Can I go to the next one then? Rule 4. Rule 4 is useful when you need to swap the base and the argument. If you swap the base and the argument, it gets flipped upside down like this. So if you swap a base and an argument, you flip the log upside down. So the proof here, log xy equals, so here we'll say let x equal bn and then y equal bm. So this would be log bn bm. Now I wonder if anybody can see what this equals. I'll give you a minute. Could you see what this equals? Any ideas?
M over N. M over N.
Which one over which one? M or N?
N over M.
Move the hand.
Okay.
Which one?
M over N.
It is M over N. Because if I have b power n and I put it to this power, the n's will cancel, leaving me with b power n. And this is using the third rule from yesterday. This m over n, you can rewrite this though. Maybe I'll do that on the next line. Let's see, I can change this into the 1 over n over m. It's the same fraction still. But the reason for changing it like that is that n over m, I can now write that as log bm bn. It's the opposite now. In other words, I've swapped where m and n are. So this will be 1 over log yx. Okay, nearly finished. Can I scroll down? Okay. Rule 5. So rule 5 is useful when you need to change the base to any other base. So for example here, we have base b, for example, and we'd like to change it to base c, for example. What you have to do then is divide by log cb. So I'll show you in a few minutes how to use these rules, but this one is the change of base rule.
It can be any number.
C can be any number, yeah, except maybe not negative numbers. But you can change it to any number you want, yeah. Okay. So the proof, we have, we can say let x equal cn and b equal cm. So then log bx, that would equal log cm cn. That would equal n over m. But if I go back here, I can see I can write this n as log base c of x. because c to the power of n makes x. So this n can be replaced by log cx. And likewise on the bottom, that can be log cb from this one here. So then that proof's finished. Okay. And the last rule, rule 6, not, again, just like yesterday, not really a rule, just some facts about special values. So can I scroll down? Okay. And what's log of 1? b to what power makes 1? 0. Can you have log of 0? No. So that's not a real number. And then, what about logs of negative numbers? Not allowed also. Okay. And also, it's normal for us to keep the base positive and not 0. Okay, now that we have our 6 rules, let's have a look at some examples then. Okay. Can I scroll down? Yeah? Yes, yeah? Okay. So my first example, sometimes some books add this in as well. Log BB, what does that equal? 1, yeah. b to the power of 1 makes b, so log BB is 1. Okay. So just some quick examples to start. What's log 3? 1, yeah. And then log 327. 3. And actually, I think we had this one last time. No, maybe not. 7, 3, 4, 3. 7 to the power of 3 is 3, 4, 3. Yes. Okay. So they're just practicing the definition of what log is. So let's look at more complicated ones now. So I want to simplify this. Log base B9 plus log base B3. So which rule would I need here? The first rule, isn't it? So that would be, yeah, 27. Okay, that's fine. Which rule would I need for this one? Which rule? Second rule. So we have to divide 25 and 5. So what do we get here? 5. Okay, and then one more like this. Log B5 squared. What rule?
2 logs.
Yeah, 2 log B5. Okay, let's look at something more difficult. 3t. 2 log 525 plus 4 log 25 125 minus log 525. Which rule can I use first? Could I use the first rule?
Yes.
Yeah, well look here, this is a good example here because there's a couple of problems with this. First you have to make sure all your bases are the same. 5, 25 and 5. So the bases are a problem, okay? Could I, let's say the bases weren't a problem. Could I put these together using the first and the second rule? Like for example, if this base was 5,
Yes.
could I put these together using the first rule?
Yes.
No.
No?
No. So I want to know why not.
Because it's your fault.
Yeah, because of the 2 and the 4 there. Okay, so be careful, but using the first rule, the first rule doesn't have numbers in the front. Okay, if I had log 25 plus log 125, then that would be log 25 times 125. Okay, so be careful. What can we do with those 2s and 4s though? What can we do with the 2 and the 4?
Yeah, multiply them with the answers of the one.
Yeah, you could bring the 2 up to make 25 squared. Yeah. But before we do any of that, we have to take care of this base here. So, my question is, should we change the 5s into 25s, or the 25 base into 5? Which?
25.
Yeah, why? It's right though. You're right, yeah, you should always change it to the smaller base if you can. So the way to change a base, when you change the base from 25 to 5, the price you pay for changing the base is to divide by log of the old base. So this is the 5th rule. Now what is log 525? 2. So this is 4 over 2. This here at the bottom is a 2. So 4 over 2 makes 2. Okay, so what should I do next?
Find the answers and multiply them with the
Subtract, yeah, which 2?
first one.
Yeah. At the front I have 2 log 525, and at the back I have minus 1 log 525. So in total I have 1 log 525. I have 2 of these, and then I have minus 1 of them. So no special rule there. Plus 2 log 5125. Now I can start putting numbers in. What's log 525? 2. And then what about this one here?
3.
This is 3, isn't it? So the answer will be 8 then. Let me just give you a small one to try, just to make sure you're okay, and then we'll just have one last thing to look at. Try this one for me. 6 log 125 minus 2 log 5 125. Okay, anyone finished this yet? Yeah. Okay, so what rule did you use first?
Changing the base.
Sorry, this one here or this one?
The first one.
And what base did you change it into?
5.
5, okay. Five, 1, 2, 5. Okay, so what's log 5, 1, 2, 5? 3. And log 5, 25? It's 2, isn't it? And then here, that's a 3. Log 5, 1, 2, 5. So let's see, 3 goes into 6 twice, so that's 4 minus 6, so minus 2? Yeah? Okay. Yesterday we saw a special number, e, and we can use it for logs as well. So we have log base e. So for example, log base e of 7.2, something like this, that's roughly 2. Do you remember what the value of e is?
2.7182.
Yeah? Yeah, keep going.
182.
182, no?
782. 81.
2.7, 1828, 1828. Okay. Now, this here is actually built in on your calculator, but it's not written as log base e. It's more normal to not write the e and just write this as ln, called natural log. But please note that base e is still there. Okay, so this can be written like this. Now, can you find this on your calculator and type in natural log 7.2, and you should get something roughly like 2, I think.
It's 1.97.
Yeah, so roughly 2, yes. So it works out as 1.97. Now please, in the exam, don't confuse these two buttons on your calculator. Can you see those two buttons? So this one here, this uses a base E. Does anyone know what LOG on the calculator uses the base? 10. And I know your calculators let you type in any base. I think there's also a button that looks like this, log box, yeah? Yeah, so this is, you can use any base then. But in the exam, when it comes to log problems, they don't want you to use this button. They want you to show your work like we've done today, okay? But it's good if you can use this button to check your answer, okay? So that's a good idea. Now let's just have a look at the graph of this log function. So here, I'll show you it here neatly. So before I start it, will this graph have a value if x is negative? Will it? What did I say about x earlier? Can you use any number for x? No, what can we not use?
Negative and 0.
Can't use negative, and we can't use 0. So when I draw this graph, do you picture the graph being on the left and the right? Or not? Just on the right. There shouldn't be anything to the left, okay? So the graph looks like this. So you can see, it doesn't actually grow that fast. If I zoom out, notice that when x is 40, what does log x look like it's roughly equal to? Maybe about 3? So why don't you type in natural log 40 on your calculator? What number do you get?
3.6.
Yeah, so I mean, let me zoom out more on the x-axis. So look, at 2000, what does it look like the value of natural log is? Yeah, well, and see what you get on the calculator. No, that 7.6 is already the calculator, wasn't it? Just looking at the graph, let's zoom out a bit more. 10,000.
Looks like 8.
Yeah, now see what you get.
9.6.
Yeah. So just compare this with the graph we did yesterday. The exponential graph grows very quickly, doesn't it? Whereas the log graph grows very slowly. Just as a quick reminder, here's the exponential one from yesterday. Now, if I keep this at 10,000, I expect this to shoot off the screen. Yeah, you can't see it because it's just shot away so quick. So you can see, by the time I get to only 2, I'm already at 8. Okay? So the log graph compared to the exponential graph, it's like literally its opposite. The log graph grows extremely slowly. Exponential grows extremely quickly. Your possible choices in the exam, they could ask you to draw log x, which we just saw looks like this. But in fact, if I said to draw something like y equals log 2x, that's just the same as y equals log 2 plus log x. What's the only difference between this and the first graph? The log 2. If I add a log 2, or if I add a number to a graph, how does that change the graph? It just makes it go up a little bit. Okay? So in fact, log 2x, if you draw it, it would look pretty much the same. It just gets raised a little bit, okay? The only real difference is if I had a minus here. What would happen if I have a minus in front of the log?
Will it go slower?
Not that, no. It just gets flipped upside down. That's all. So I'll show you here neatly, okay? So first one, there's log x. And then, for example, log 2x. It's not much of a difference, is there? It's the same basic shape, okay? What about log minus 2x?
It's going to be the opposite.
Yeah, well, we can't really use minus, so we won't bother looking at that one, okay? And then the last one I want to show you, minus log x. Can you see it there? It just gets flipped upside down. So really there's 2 basic graphs you need to know for log. This one here in red, this is like log AX. And then in green, this is minus log AX. Now, what's interesting about these log graphs is I could give you something complicated like this, y equals log x squared, and you might say, oh, how could I draw this? But what could we do to log x squared?
2 log x.
Yeah. So which graph would that be like? It would just be like the red one, wouldn't it? Except we multiply it by 2. So it doesn't really matter if there's a b in front here as well either. it's still just going to be increasing very slowly. What about something like this? Well, that's the same as log x power half, which is the same as a half log x, which again is just the red graph. So that's the nice thing about log graphs, is that even if you have something complicated inside your log, you can use the rules to simplify it, and it's easy to make the graph then. Okay. Did you do all of this with Joan as well? Is that yes or no?
We didn't do the graphs,
Huh?
we didn't do the graphs.
Okay, so you haven't seen the graphs yet then. Okay, but the rules are okay? You know how to use them? And have you practiced any from this page?
Yeah.
Which ones?
1, 2, and 3.
Well, hang on, let me ask it this way. Have you done the last 3 in each?
Yes.
Really?
More. Almost everything. Almost everything. No,
You did almost everything?
yeah.
Alright, well then why don't you do everything then? Why don't you finish it so? Are you saying you're nearly finished the page?
Yeah.
Is that, are they talking nonsense or?
It's easy to work, it's here. Yeah, I can show you that one.
Well, I'll tell you what, we've got a few minutes left, so why don't you just try these for a few more minutes, and then I want to talk to you a little bit about your maths project as well. So just try these for a few minutes, and we'll talk about your maths project. So if you haven't really finished them, why don't you finish them?